Hey there, chemistry students. This is Miss Ruark. This is Vodcast 9.1, where we're going to talk about acids and all you want to know about acids. Okay, so let's do a little review over naming acids. Remember, this is review, so I'm going to go quickly. All right, so naming acids, we know that all acids start with a hydrogen, so we can have a binary acid, and a binary acid is when you have a hydrogen with a nonmetal, such as hydrochloric acid. And you can also have an oxyacid. And an oxyacid is a hydrogen with a polyatomic ion, and it has to have oxygen in it. All right, binary acids, the name depends on the state of the acid. If it's not aqueous, we just say hydrogen plus whatever the nonmetal is. So this would be hydrogen chloride because it's a gas. If it's aqueous, we have to name it as an acid. So HCl aqueous would be hydrochloric acid. All right, just review. All right, with an oxyacid, naming does not depend on the state, whether it's aqueous or not. So if you see something that is an oxyacid, then you're going to name the polyatomic ion, replace ATE with IC. Remember, I ate something icky, and then replace ITE with OUS. If you need to change the root for pronunciation, change the root, such as sulfuric acid. We don't want it to be sulfic acid. It sounds funny. And then we add acid to the end of the name because we want to let everybody know that it's an acid. All right, then writing formulas for names. So first we have to identify what is the anion that is involved. If the acid starts with hydro, then it's not a polyatomic ion, meaning your anion is not a polyatomic ion. And if there's no hydro, then the acid ends in ATE, then if our acid ends in IC, then our polyatomic ion must end in ATE, our ate something icky. If there's no hydro and the acid ends in OUS, then the polyatomic ion must end in ITE, and you would use the correct formula from there. If there is a prefix on the acid name, that's because there's a prefix on the polyatomic ion, such as hypochlorous comes from hypochlorite. Perchloric acid would come from perchlorate. And then you use the charge on the anion to decide how many hydrogens you're going to have in your formula. So if the charge on the anion is -2, then you have 2 hydrogens. All right, just some examples. We'll go through them very quickly. Carbonic acid, it has no hydro at the beginning, so this right here has to be a polyatomic ion. IC gets changed to ATE. Carbonate is CO3 with a -2, and since this is a 2, then we have to have 2 hydrogens, so it's H2CO3. Okay, nitrous, OUS gets changed to ITE. Nitrite is NO2 with a -1 charge. We put the hydrogen in front. We need 1 hydrogen, so HNO2. Okay, skip to number 4, hydrochloric. Oh, let's not do that. We do that all the time. Let's skip to number 7, hydrosulfuric acid. Hydro means that it's going to be hydrogen and whatever this is. So sulfuric means it's sulfur. Sulfur has a -2 charge, so it's going to be H2S. Okay, you can do the rest of them on your own and come check them with me. This is just review. Okay, so types of acids. We have a couple different types of acids. One of them is what we call an Arrhenius acid. An Arrhenius acid is an acid that produces hydrogen ions when it's in an aqueous solution. And a base is something that produces hydroxide ions when it's dissolved in water or in an aqueous solution. The problem is it limits only the acids that are in aqueous solutions. So we only have one kind of base, which means that ammonia, can't be a base by the Arrhenius definition, but we know that it is. Okay. So we have another type of definition. We have the Bronsted-Lowry definition. And by the Bronsted-Lowry definition, and this is the one that's most widely used, an acid is a proton donor or hydrogen donor, and a base is a proton acceptor. Now, we call it a proton because what is a hydrogen? A hydrogen has 1 proton and it has 1 electron and it has no neutrons. So if we take away if we make it an ion, we take away that electron, what do we have left? We have just a proton, so that's why we call it a proton. Okay, acids and bases in Bronsted-Lowry always come in pairs. We'll talk about that more later on. Okay, HCl is an acid. How do we know? Because when it's dissolved in water, HCl breaks apart into H plus and Cl minus. Okay, and right there, that hydrogen is being given away. It's being donated, and so that's why we say that HCl is an acid. Well, by the Bronsted-Lowry definition, water, H2O, can actually break apart into HOH, right? Okay, so water can break apart into hydrogen and hydronium ions. And because it makes this hydronium ion, it would be considered a base. But guess what? It can donate this hydrogen and it can also accept a hydrogen. So it's going to behave as both an acid and a base. We call that amphoteric, and I'm sure we've come across that a little bit later, either in this vodcast or in the next one. All right, the last one that we needed to bother with is the Lewis definition of an acid. The Lewis definition is based on bonding and structure, and it includes any acids that could be out there that do not have hydrogen at the beginning. It's kind of weird, right? Okay, so what determines whether something is a Lewis acid or a Lewis base? Well, a Lewis acid is one that accepts an electron pair to form a covalent bond, and a base is one that donates an electron pair in order to form a covalent bond. And that's the only difference between them. Now, we're not going to come up with this one too much. We're not going to emphasize it. We're not going to use it that much, but I did want to present it to you so you would know the three types. Okay, I told you in the Bronsted-Lowry definition that acids and bases always come in pairs. We call those conjugate acid-base pairs. We use the Bronsted-Lowry definition to define these. And a conjugate base is what remains after a Bronsted-Lowry acid gives up a hydrogen. Okay, so for example here is our acid. How do we know? Because it has hydrogen at the beginning, of course, and it can give away that hydrogen. If it gives away that hydrogen, it becomes F minus. Well, this would be your acid, so this would become your conjugate base. Okay, well, guess what? If you've got an acid and a base, or an acid and a conjugate base, you probably have a base. Since this is the acid, this has to be the base. And look, it has taken on a hydrogen, and so this would be considered your conjugate acid. So here's your pair here, and then in the orange, we have our other pair. Okay. The conjugate base, like I just showed you, is what's formed when a Bronsted-Lowry acid or base gains. This should say conjugate acid. Let's fix that. The conjugate acid is what's formed when a Bronsted-Lowry base gains a hydrogen. Okay, so here's your base. It took on a hydrogen, and that's your conjugate acid. The stronger the initial acid is, the weaker the conjugate base is, and vice versa. So if you have a stronger acid, you'll have a weaker conjugate base. If you have a weaker acid, you'll have a stronger conjugate base. And then the stronger the base, the weaker the conjugate acid will be, and vice versa. All right, so then what are the strong acids and bases that you need to know? There are 8 strong acids that you need to concern yourself with, and you need to know these. You have to memorize these, because if you memorize these, every single other one is weak. Okay, so write these down. You have hydrochloric acid, HCl. We have hydroiodic acid, HI. We have hydrobromic acid, HBr. You also have nitric acid, HNO3, chloric acids, HClO3, perchloric acid, HClO4, sulfuric acid, H2SO4. What am I missing? 1, 2, 3, 4, 5, 6, 7. Oh, periodic acid, HiO4. There we go. Okay, and then we have strong bases. Strong bases would be anything that has a group 1 metal attached to it with a hydroxide. So examples of that would be potassium hydroxide, rubidium hydroxide, cesium hydroxide. What else am I missing? Sodium hydroxide. I know I was missing something. Okay, and then any hydroxide that's mixed up with barium, calcium, and strontium. So barium hydroxide, calcium hydroxide, and strontium hydroxide. There you go. So there are your strong acids and your strong bases. You just have to memorize them. If you memorize them, it will make this unit a whole lot easier. Oh, hey guys, guess what? That's it. All right, so I guess I will see you in class. Bye.